Hello everyone, let's talk about building your own computer. In this video, I will tell you the basic parts that you will need and give each one an overview. Some of these parts I've already covered in previous videos, and some of these parts I haven't covered yet but will at a later time. So let's dive right on in. Why would you want to build your own computer? Well, for the fun of it, if you enjoy types of things like that. For the experience, especially if you're in the IT field, it really helps you look a little bit better. For the knowledge, again, if you enjoy that type of work or if you're in IT, it really helps kind of boost your knowledge. Cost can be a factor as well, although sometimes building your own computer can be more expensive than buying one for the reasons you need, but at the same time, it can be worth it. Specific needs as well, such as gaming or graphics design or even programming, as well as building for the future and adaptability. Sometimes when you buy a computer, you buy for what you need, and that can make it hard for expanding on the future because it was pre-made. But when you build your own, it's a lot easier to swap out parts. It's a lot easier to really build for the future. So what parts will you need? Well, you'll need a computer case, a processor, a motherboard, RAM, hard drive, operating system, a power supply unit, a cooling system, and we'll also cover some additional items that you may want. So now we're going to go into more detail about each of those parts I just discussed and then a few extras. Computer cases all come in different sizes and shapes. Some are a lot larger while some are smaller form factors. Some are squared off while some are more rectangular and boxy, and then some of them even have lots of angles. Some are you got a lot of different colors. Some even come with clear sides so you can see inside your computer, and those are actually pretty cool if you take advantage of the clear side and put in some colorful fans and so on inside the computer. You can really make it look pretty cool and flashy. The style is completely up to you. You have to just ensure that your case will fit all you need to build your PC. You don't want to build the case too small to where you can't get all the power and peripherals you'll need, but you also got to be careful with airflow as well. If you get too much packed into too small of a case, you'll limit your airflow, and that could overheat some of your internals. Also, keep in mind that some cases come with fans and some don't, so if they don't come with fans, you'll need to buy additional ones. Even the ones that do come with fans, you might consider looking at buying an extra fan or two. So now your CPU, or central processing unit, or processor, is your computer's brain. Here's where all of the calculations and computing takes place. Make sure that you pick the correct CPU for your needs. CPU performance is measured by gigahertz, and they also have some things called cores. Cores handle different tasks. Some tasks only require one core, while others require multiple cores to complete that task. Thread count is also something to consider. Hyperthreading is a newer technology which essentially creates a virtual core, which ideally turns a dual processor into a quad processor. So, and that's virtually. You still have a dual processor. Or if you have a quad processor, it'll virtually turn it into an 8-core processor. Due to performance and architectural changes, be sure to buy the newest and most up-to-date processors from either AMD or Intel to better prepare your computer for the future. If you buy a couple gens back, it might be good for what you need now, but it might not be good for what you need in 2 to 4 years. I just mentioned two brands, AMD and Intel. Which is better? That's a huge debate that we're not going to cover in this video. Do keep in mind that AMD allows you more freedom with overclocking your processor than what Intel actually allows. Overclocking is a way to make your CPU run faster. I rarely recommend it, but that's just me. Some people love overclocking. Personally, I think you should get a better processor and a better graphics card rather than taking your current processor and ramping it up. So, and if you do decide that you want to overclock your processor, make sure you have proper cooling, which we will cover later on. So now onto your motherboard. You must find a compatible motherboard that will fit inside your case, but also compatible with your processor. The motherboard is what brings all of your computer components together, hence the name motherboard. If you plan on overclocking, make sure that your motherboard also allows for that. And Just like cases, there are several sizes of motherboards, but we're only going to cover the traditional three sizes: the ATX, Micro ATX or MATX, and the Mini ITX. Larger motherboards generally allow for more fans, hard drives, RAM, PCIe ports, and so on because they're larger. Personally, they're my favorite to build with because they have a lot more room and you can customize them a lot easier, or customize your components a lot easier. Motherboards don't necessarily have a huge impact on your computer performance, so whatever size you go with, you're not necessarily messing with or sacrificing performance, so to speak. But be sure whatever motherboard you go with, make sure it's a good quality, because that'll save you headaches in the long run, because it's less likely to have components fail or mess up in any essential way, such as like some of these ports on the back might actually, like network ports, might actually go bad. Better quality motherboards, that's not likely to happen. The one that I built my computer with is an Asus, and it's been great for me. Quick note, I would highly suggest that you ensure that your motherboard and processor are both 64-bit architecture. Your processor decides the architecture, but your motherboard must be compatible with it. The other architecture is 32-bit. It's kind of older, but also the power is limited, so I would highly suggest 64-bit. Plus, that's the way a lot of companies are starting to move, whether you're looking at Windows, Linux, or Mac operating systems. Their parent companies are really starting to go more towards the 64-bit architecture. RAM, or DRAM, is random access memory. RAM is important because it's actually the middleman between your processor and your hard drive. RAM only keeps memory of what it needs to run, whereas the hard drive stores all of your data permanently. The processor also only holds what it needs to run, and it has even less memory of what it needs than what the RAM does. RAM is also volatile and loses memory when it loses power, unlike the hard drive. The processor is the same thing. It loses memory, loses whatever's in its memory banks whenever you power off your computer. Of the three, the processor is going to be the fastest component. I always recommend a minimum of 8 gig of RAM. No matter what computer you're building, no matter what you're doing, you need at least 8 gigs of RAM. However, if you plan on building an extremely powerful PC, you should consider 16, 32, or even 64 gigs of RAM. How much RAM your computer can handle is based on your motherboard. 64-bit architecture computers can handle over 128 gigs of RAM, whereas a 32-bit machine, don't quote me on this, but I'm wanting to say it's 16 gigs of RAM. It's been a while since I've looked at that, but anyways, point is 64-bit is more powerful. How much RAM you need really just depends on what you're building your computer for. It doesn't hurt to start with 8 or even 16 gigs of RAM and increase from there if it's necessary. RAM sticks come in different sizes. So as an example, we're going to look at 16 gigs of RAM. You can get a 16 gig stick of RAM, which is called a 1x16. You can also have 2 RAM sticks that are 8 gigs, so 2x8, or even 4 gig RAM sticks to get that total of 16 gigs, and those are called 4x4. Some believe it's best to just have 1 stick of RAM, whereas, so in our example, that would be a 1x16 gig, 1x16 stick of RAM for 16 gigs of memory. Some believe that it's best to have multiple, so 4 gigs RAM sticks, so a total of 18 gigs. Personally, I'm kind of torn between the two. I see the pros and cons of the way both people do it, so I just suggest that people go right down the middle. If you're building a 16 gig computer, go with 2 8 gig sticks. If you're building an 8 gig computer, do 2 4 gig sticks. Personal preference, if you ask me. A question I would really like to answer is, which is better, more RAM or faster RAM? Faster means better performance, but more RAM tends to be better for most people due to having more memory that can be used. Just because it's faster doesn't necessarily mean that it's going to have the better performance. One other thing to know about RAM is that there are some double-sided RAM sticks out there, and some are single-sided. It's an argument on which is better, and I'm not going to tell you either way, but I will say that I tend to use double-sided. I will also say this: ensure that you are using DDR4 RAM and your motherboard supports DDR4. That is the newest technology, and so again, build your computer for the future. If the motherboard does not support DDR4 RAM, find a new one. Hard drives are where all of your applications, photos, documents, and so on are stored. Your operating system also runs on it, so it needs to be quick and reliable. For your hard drive, I would recommend buying an M2 drive. It connects directly to the motherboard, so it's actually the fastest of all hard drive options. If your motherboard isn't compatible with an M2 drive, or buying one is too expensive, which I totally understand, go with the traditional solid-state drive that uses a SATA 3 connection. But you should always install your operating system and your applications on your fastest hard drive. So if you have multiple hard drives in your computer, install your operating system and applications on the faster one, and then on the slower one, and put all of your other data such as photos, documents, PDFs, and anything extra on there. Your power supply unit is extremely important because it powers your whole computer. So it has to be powerful enough to supply power to all of your fans, hard drives, motherboards, processor, and anything else that you might add to your computer. There's no need to buy a power supply unit that has 500 extra watts than what you need, but definitely make sure that it can power what you currently have and cover any expansion that you might be looking at. So I always suggest going about 100-150 watts more than what you need right now, because if you add an extra hard drive, extra fan, or something in your PCIe slot, you'll want that extra power. I also suggest spending the extra money on a modular power supply unit. They allow you to pick and choose what cables you need, and so that way you don't have a bunch of cables just kind of going everywhere. You don't have a bunch of cables that you don't need, like a traditional power supply unit might provide. You know, because like in my computer, which you'll see in the next video, I've got a bunch of cables just kind of tucked away because I don't have a modular power supply unit, so it doesn't look clean and it doesn't look pretty. So be sure to make sure that it's powerful enough for what you need. It's not too powerful, but it can handle some expansion. And I would suggest a modular one, so that way you can pick and choose what cables you need, and it looks a lot cleaner inside your case, especially if you're going with a clear case rather than something that covers your whole, covers all your internals. So let's cover some additional items that you might want for your computer. So let's start with a graphics card. A GPU is a graphics card that really helps if you're going to do any gaming or a lot of graphics work. GPUs help take some of the stress off the processor because it has VRAM inside of it, which is aimed more for graphics work than traditional RAM. But it also overall just kind of eases some of the pressure on other components on your computer. Not only will it help your processor perform the task better, but it'll also render your graphics at a faster rate. And on the plus side, your processor will be freed up to use for anything else. So if you're rendering a video, you can still go on and do your word processing or Excel spreadsheets and so on and so forth. So it really helps you be more productive in the long run. Cooling is an extremely important topic. I always suggest a powerful fan and heatsink for your processor so that it stays cool, performs well, and it has the option for overclocking without overheating. And you can actually see some of mine, or part of my heatsink right now, and my fan. We'll cover that in the next video. I also have 3 additional fans in my tower to keep it extra cool, but really 2 fans would have been good enough for me. If you're building a computer for gaming or a server, I would highly suggest at least 2 fans on top of having a fan on your processor's heatsink. Helps your computer maintain a nice cool temperature. If you have a clear case, I suggest buying some fans with some lighting just to kind of make it look cool. Liquid cooling is also an option. If you go this route, do lots and lots of research to ensure that your computer case will fit the cooling pieces. You have all the proper pieces you need, and when you're putting it together, be extremely careful because you don't want to damage any of the internals on your computer. So for additional storage, I've already mentioned using an M2 or a solid-state drive for your operating system and applications, but you should get, in my opinion, an extra hard disk drive, or solid state drive for additional storage. If you can, also buy an extra one for backing up all of your data in case your main hard drive crashes. So for an example, for a basic computer, get an M2 hard drive that is 128 gigs, get a terabyte spinning drive for extra data, and then get a 2 terabyte spinning drive to back up both your solid state drive and your hard drive to the 2 terabyte drive. It sounds like a lot of extra work, but should any of your hard drives ever fail, or should you accidentally delete something or overwrite something, you can go back to that backup and pull from your data. Your operating system is obviously important. You can go out and buy Windows 10. I believe the current running price is $139 for the home version. I don't remember what it is for the Pro version. But you can also download a version of Linux for free. Whichever operating system you go with, make sure that your architecture, whether it's a 32-bit or 64-bit, matches up with whatever processor and motherboard that you go with. Windows 10 can be more beneficial for most users, while Linux is better for those who want to learn about Linux itself, as well as those who like using command line interfaces. If you desire, you can also install multiple operating systems on one computer, so you can buy both Windows and download a free version of Linux and put them both on the same hard drive. As far as mouse and keyboard, buy a Bluetooth one, buy a wired one, whatever you need. Monitors, they're a little trickier. You basically, like keyboards and mouse, buy whatever suits you. If you're looking for gaming, then go out and buy a nice 23-inch, 24-inch, 32-inch, whatever that's got 1080p, 4K, whatever you're wanting. If all you're doing is word processing, basic monitor, I wouldn't ever go smaller than a 23-inch for a desktop computer. Also, you can do a TV. For example, my Linux is hooked up to a 32-inch TV that's sitting right here. The TV's 10 years old, but gets the job done. If you are building a high-end computer for graphics design or gaming, I would suggest 1080p or 4K monitor. Optical disk drive is personal choice. They're going out of style. Not a lot of computers are coming with them. Most things are downloaded, or a lot of people are going to USB these days. SD card compatibility, that's something some people really prefer to have. Others don't really care. I do suggest that for those of you that plan on getting into photography or are already in photography or using professional cameras, those typically use SD cards. Sometimes they'll plug into USB, but make sure that your computer is compatible in some way. PCIe cards to consider would be network cards with additional network ports, SATA cards, cards with old connections that your motherboard doesn't have, such as VGA or DVI, extra USB 3.0 or 4.0 or even USB-C ports, or even an M2 compatible card. So if you want an M2 drive but your motherboard isn't compatible with it, or later on, in a couple years, you're like, man, I really want an M2 card, you can go out and buy a PCIe card that can fit an M2 and just plug it in. So now I bet you're starting to wonder, where do I get all these parts from? Well, that's pretty simple. Buy online, go to a local store, really just anywhere that sells computer parts. I'm not getting paid to say this here, but one of my favorite places to go is PCPartPicker.com. I'll put that down below so you can click on it and check out their site. What's great about them is that they help make sure that all of your parts are compatible. So I was talking about making sure your CPU and your motherboard are compatible. This will help with that. Not only that, but they make sure that you're not missing anything. So if you don't have something, so they have a whole list, so if you kind of forget, oh man, I need this part, well, they've got a list there of parts to check out, so you shouldn't forget anything. They also have computer builds that other people have done, so you can check those out, rebuild, like basically build identical things to that. They also compare prices, so you can make sure that you are getting the best price, whether it's from Amazon, Best Buy, Walmart, Newegg. wherever that you might be shopping from, they've got a lot of prices that are for each product that are compared, so you can make sure that you're getting the best deal. Again, you can shop anywhere online that sells computer parts, find a local store, just see who has the best deals. And my biggest suggestion is do not rush. Make sure that you research your parts, make sure that you buy compatible parts, and make sure that you're building your computer for you. If you're coming up $50 short for the build, wait a month before you start buying things. Just make sure that you build the computer that you want, and not a computer just because it's like, this is the cheapest part, I'll go with it, even though it's not entirely what I want. Make sure you get what you want. So when it comes to putting together a computer, what is the best practice? Well, make sure that you are grounded throughout installation. You don't want any electric shock touching your computers. Companies sell mats and wristbands to help with this. Myself, I do things the wrong way, so I don't suggest this, but I will touch the metal and hope that I'm grounded, and then I will reach in and start working on my other computer parts. Again, not the correct way to do it, but make sure that you are grounded before you start messing with internals. As far as what order to put everything together in, that's personal preference. My suggestion is put your processor on your motherboard, and then you want to put your case fans inside your case. You want to then put your motherboard in your case, install the RAM, install the CPU, heatsink, and fan to the processor itself. Make sure that you use thermal paste. I cannot stress that enough. Properly apply thermal paste. If you don't, you risk your processor overheating even with a heatsink and cooling fan. Install your power supply unit. Place all of your hard drives in the correct slots. Install any PCIe cards that you need. Connect all of your power cables from your power supply to their respective devices and ports on the motherboard. Connect any peripherals such as keyboard, mouse, monitors, and so on. And then power up your computer and install your operating system. How you might do that, well, it depends on how you purchase it, but typically what I would suggest is putting your operating system, whether it's Windows or Linux, on a USB. And when you put it on your USB, you'll plug in and you'll boot into your BIOS, and then you'll boot from there into your USB and install your operating system on your hard drive. Again, this order is done differently by everybody. That's just what I would do, what I have done, and it's what I suggest for you, but do what's best for you. Just make sure you get it together. So I know I threw a lot at you in this video. I know it was a fairly lengthy video, so thank you for staying with me through this process and watching it all. Ask any questions and comment below. Don't forget to like and subscribe, and I'll see you in the next video. Thank you.